This is IXL 9E13, and in IXL 9E13, it's really just asking you to associate a three-dimensional shape with its net. Sometimes it'll give you the net and say which of these three-dimensional shapes matches it. Sometimes, like here, we have the three-dimensional shape showing up here, and we're asked to associate it with the net. Now, what a net is just a flattened out version of kind of the outside surfaces of the shape. Like, so for example, here, this thing, you could think of this as like a can of beans. If you were to get a can opener and make it go around the edge of your can of beans here, then you could flip up that top, do the same thing with the bottom. And then if you cut a side up the can and unroll it, you'd end up with a rectangle, and these would be the top and the bottom of the can. If you're wondering how this rectangle ends up coming from this curved surface, just think of a toilet paper roll at home. If you just cut a toilet paper roll and you flatten it out, it becomes a rectangle, just like that. So this is a cylinder flattened out. You see that every part of the outside surface ends up matching up to something we see here. That's how you can recognize a net from a shape, and how you can picture if I were to fold this up, or in this case roll it up, and assemble it just like a cardboard cutout, what would it look like? You should end up with this here. Now, one way to make sure you've got the right net is just take a look, like see here, this hexagon here. Nowhere in this shape would you find a polygon that's a hexagon. That's one dead giveaway that this can't be the right answer. This is the only one that makes sense. The more of these you do, the more they become innate, and that's really the goal of doing this IXL here. This one here, you say to yourself, okay, I've got a triangle base, some rectangles here. Even though I've got a rectangle here, there's no triangle showing up, so this is the only one that can make sense. And it does make sense in that if you think here, if I've got a triangle base, another triangle base at the other end, then the number of rectangles, there's going to be one rectangle as a face for each of these edges of the base, right? And that's going to have to make sense. If you're looking at one here where they give you a shape that has a pentagon as a base, then you know, okay, my net is going to have that pentagon showing up. And you have a pentagon showing up here, a second pentagon, that's the guy around the back here. And since each of these edges here, there's 5 of them, each of them is associated with a rectangle, I should end up with 5 rectangles like this. Now here's a good example of how every net isn't the only way that you could draw a net, right? Like it could be that I could have the pentagons both coming off the last rectangle here, and that would be a perfectly good net as well. There's one standard way they have to be. There's several different ways you can have a net of a cube like that we're seeing here. In this case, though, because this net can be associated with this shape, then I know I've got the right answer over here. This one here, again, if you're looking at this, you're saying, okay, all the shapes that I'm seeing are squares. The ones that I can't see on the other side, they're just like a die, this cube is. Oh, they're all going to be squares, so I wouldn't end up with anything with any triangles, just 6 squares like I have here. Though notice in the last question we saw, we had a net of a cube showing up as a potential wrong answer. This is a different net from that cube, but again, if I fold this up, I will still end up with a cube because not every net necessarily has to be the same. For this one here, again, I start to get the idea that when I have a whole series of rectangles, they get wrapped around. We call these the lateral faces of a prism, with the octagon being the base on both sides here. No triangles are showing up in my net. Here's this guy can't be the right answer. Instead, it's this one right there. In this one here, you see, okay, I've got 4 triangles and a square that they're all connected to. This is your classic net for a pyramid, where you have one polygon that's different from all the triangles that come off it, and all the triangles folded up together give you a nice pyramid shape like this one here. This shape here, a cone, maybe the first time you see a net of it, it's a little bit surprising. But the way that a cone breaks down when you cut it open is the base is going to be a circle. You can already spot that here. But this shape here, which if you spot it, it's like a sector of a circle. It looks like maybe about 200 degrees worth of sector of a circle. If you are to cut open a party hat from when you were a kid, cut open one of those party hats and flatten it out, it will actually make the sector of a circle. And there's actually a relationship between the ratio of this length down here that we call the slant height, which is the same as the radius of this sector here. The relationship between this and the radius of the base is going to be the inverse of the relationship between this angle and 360 degrees. But you don't need that in order to be able to recognize that a flattened out cone is going to have a net that looks like that. Lastly, we'll do this one last example here where you've got a hexagon, right? This hexagon here means that I got to have hexagon showing up in my shape. There's only one of these that makes any sense at all. So you will end up maybe occasionally getting ones that will be a bit of a challenge, like maybe it's worth talking about this last one here, because you do have two kinds of pyramids here, and all around the lateral faces, the sides that are exposed to the air when the thing's sitting on its base, like it is here and here, they're triangles all the way around. But notice that the base of this one here is a triangle as well. So every face of this guy is a triangle. Every face that's showing up, all the divisions here in the net are triangles as well. This guy's got a square base at the bottom. Since we don't see any square base here, we're not dealing with a square pyramid. Instead, we're dealing with a triangular based pyramid.